So welcome to the fourth video lecture of subject Digital Signal Processing KEC 503. The topic is circular convolution and the linear convolution, and I am Dr. Amit Garg, Associate Professor in DC Department of AKGEC. So in this video lecture, I will discuss about the circular convolution, which is basically the property of discrete Fourier transform DFT, and linear convolution. Because linear convolution is not the property of DFT, and we are studying this under unit 4th. So we will see that how linear convolution will be calculated using the circular convolution. Means linear convolution can also be found directly, or it can also be found using the circular convolution. So here in this particular unit, because the property of DFT is the circular convolution, so we will see that how we will calculate the linear convolution using the circular convolution. Okay. So first of all, I'll discuss about the comparison between circular convolution and linear convolution. Okay, circular convolution and linear convolution. Okay, so if you can see this that under linear convolution, the length of input sequences can be different. Means if we are having two sequences, both the sequences can be of different length. There is no such requirement that sequences will be of equal length, but the requirement or restriction in case of circular convolution is that the length of the input sequence should be the same. Means if we are doing the circular convolution between two sequences, then the length of both the sequences must be equal. So because here we can see in linear convolution both the inputs can be of different length, so there is no requirement of zero padding. So we will not do the zero padding in case of linear convolution. However, in case of circular convolution, because the restriction is that both the sequences should be of same length, so the length of the input sequences are different. If the length of the input sequences are different, then we have to make it equal by adding the zeros at the end of the sequence in which number of elements are less. And another important thing is that in case of linear convolution, the sequence that is given to us is not periodic. Okay, so the input sequence need not to be periodic. If it is periodic, even though you can calculate the linear convolution, but there is no such restriction that your sequence should be of periodic. And in case of circular convolution, at least one of the sequence need to be periodic, or it can be made periodic by the periodic extension. Okay, so at least one of the input sequence should be periodic or extended. Then in case of linear convolution, again the output sequence is not periodic, the output sequence is non-periodic, and here in case of circular convolution, the output sequence is basically the periodic sequence, and you can see the periodicity is the same as that of the input sequences. As we have already discussed that input sequences are of equal length, so you can say if it is periodic, then it will be then periodicity is the same as the length of each of the sequence. And here you can see that in case of linear convolution, the length of the output sequence will be greater than the length of the input sequence, and here the length of the output sequence is same as that of the input sequence. So what is the length in case of linear convolution? So let us suppose we are having two sequences. Let us say the length of first sequence is L1 and length of second sequence is L2. Then the length of the convolved sequence is basically, let us say we are saying it L. So the value of L will be equal to L1 plus L2 minus 1. So this is the length of the convolved sequence in case of linear convolution. However, in case of circular convolution, as both the sequences are of equal length, so we can say L1 equals to L2 equals to L. Then let us say length of the convolved sequence will be L3. So the length of this convolved sequence will also be equal to this length L. So you can say if we are having two sequences each having length 4, then the convolved sequence is length equal to 4 here in this case of circular convolution. But if we are having two sequences, let us say both having length 4, even though we are calculating linear convolution, then the length will become 7. If we are taking L1 and L2 both has 4, and here if we are taking L1 and L2 equals to 4, then the length of the convolved sequence is also 4, but here it is 7. Okay. So these are the differences between the linear convolution and the circular convolution. Now first of all, we will see that how we will compute the circular convolution between two given sequences. The foremost requirement is that both the sequences must be of equal duration. If the length is not equal of both the sequences, then we have to, first of all, we have to do the zero padding in the sequence in which the number of elements are less. Then we can apply any of these techniques. So basically, if you will see, then there are three methods by which we can compute the circular convolution between two sequences. First one is the graphical method. It is also called as circle method. Second one is you can say the matrix multiplication method, and the third one is the DFT IDFT method, and it is also called Stochamp's method. So by any of these three methods we can compute the circular convolution between two sequences. Okay. So now we will discuss something about these methods, then we will do some mathematical formulation of it, or and we will solve some numericals based on this. Okay. So we will see the graphical method. Okay. So as the name suggests, based on some graphics we can compute the circular convolution. It is also called circle method. Why? Because the sequences are lying on the circle. Okay. So that's why it is also called the circle method. Now if no method is given to you, then default method is this one method. Means by default you have to assume that you have to solve a particular numerical using this graphical method or circle method. Then matrix multiplication method, it is a quite simple method. You can say you can very easily find out the circular convolution between two sequences, but when we will solve it analytically, then this method is only used when it is asked. Means we cannot solve using this method in your question paper. If question is asked, then you cannot solve using this method. You can check so easily using this method. So this is for checking purpose, you can say. And third method is DFT IDFT method. This method is used when it is mentioned. Okay, when it is mentioned in the question. Okay. Now we will talk about the complexity. So if we will talk about the complexity, then this is the method which is the most complex method, because we are working with the matrices. So this is the most complex method. Okay. And this is again the moderate complex method, and the easiest method, less complex. This is the less complex method. This method can be solved using a very simple algorithm. Although we are discussing that complexity based on the machines. So machine can easily use this method to perform the analysis, and the complexity is very less. But however, it is seen when we will solve the question analytically, then we will find that this method is the most complex one. But as per machine, this method is the less complex method. Okay. So first of all, let us start with the circular convolution method, graphical method. So this is the example. Compute circular convolution of two sequences. So these are the sequences given as 1 1 2 2 and 1 2 3 4 using graphical method. And how we will solve it? Okay. So first requirement is that both the sequences need to of equal duration. So we can see here that length of the sequence x1n is 4 and x1 is 4 again. So we can directly apply the circular convolution without any zero padding. Okay. So how we will solve it? So we can see the formula for performing circular convolution is defined here. This is the circular convolution of two sequences, and this is basically the definition of circular convolution. So x3m will be equal to summation n equals to 0 to n minus 1 x1n into x2 m minus n mod n, or you can also write m minus n mod n like m minus n mod n, and the value of this is nothing but m minus n plus n. So this is the formula here. Okay. So because this mod n we are moving on the circle, so that's why we have put it over here mod of n. Okay. So if the number of elements are 4, so we have to take mod of n, that value will be equal to 4. Okay. So now we are implementing this. So the method in graphical method, what we will do, we will write first of sequence 1 here, and the elements are arranged like 1 1 2 2. So you can see here the sequence is x10 is 1, x11 is 1, x12 is 2 and x13 is 2. So you can write your sequences on the circle like this, and we will write the second sequence here. So again the second sequence will be x20, x21, x22, x23. You can write 1 2 3 4 here. Now if you will see, then what value we have to solve here? according to the mathematical formulation, if we will put m equals to 0 here, so the first value x30 will be equal to summation n equals to 0 to n minus 1, n is 4 here. So this will become n equals to 0 to 3 x1n into x2 minus n mod 4. Okay, so we have to compute this. So what we have to do? So if you'll see x2 minus 0 mod 4 will be equal to x2 0, nothing else. So what we have to do, basically we will take x1n and we will multiply with x2 minus n. x2 minus n is the mirror image of the sequence, x2n. Okay, and then we will multiply the individual sequence and then the product, and then we will do the summation. Okay, so this is basically the first value of the convolved sequence. Okay, so what we will do, we will, according to this expression, we want x1n multiply with x2 minus n mod 4. So you can see here, this is x2 minus n mod 4. How we have obtained this? We have obtained this by simply calculating value x2 of minus n. So if you will solve this x2 of minus n, the value of x2 0 equals to 1, and these sequences are interchanged when capital N equals to 4. We can see this here, x2 minus 0 mod 4 will be equal to x2 4, and that is equal to x2 0. So x2 minus 0 is same as x2 0. Okay, so x2 minus 0 will be same as x2 0. x2 minus 1 mod 4, it means that value will become x2 3. So x2 minus 1, this value will become x2 3. So that's why we have written it over here. Similarly, x2 minus 2 mod 4 will become x2 2. So same value will be retained, and x2 minus 3 mod 4 will become x2 1. So x2 1 is this value, so it will come over here. Now what we will do? We will product the individual sequence values. Okay, so here we can see x1 0 into x2 0, that value equals to 1, and this 1 into 4, that will become 4, 2 into 3, that will become 6, and 2 into 2, that will become 4. Now we will add all these values. So the addition will give you 1 plus 4 plus 6 plus 4, the value is 15. So this is the first value of circularly convolved sequence. Okay, then we have to perform, then we want second sequence of the circularly convolved sequence. So what we have to do? We will shift this sequence by 1 unit in anti-clockwise direction. Okay, so this will become x2 1 minus n. When x2 1 minus n will be there, then this value will come over here, this value will be here, this value will be here, and this value will be here. So we will get this value. Okay, so we can see the sequence value is 2 1 4 3. Again we will do the multiplication with this x1n into x2 1 minus n. Okay, so this is the value, 1 into 2 2, 1 into 1, that is 1, 2 into 4, that is 8, and 2 into 3, that is 6. Now again we will add up all these sequence values. So this is 2 plus 1 plus 8 plus 6, so we will get the value second, and this is the second value of the circularly convolved sequence. Now we have to calculate third value. Third value is, we will again shift the sequence by 1 unit in anti-clockwise direction. So we will get x2 2 minus n. So x2 2 minus n means we will again shift it. So if we will again shift it up, then x2 2 minus n will become this. So 3 2 1 4. Okay, this is basically the x2 2 minus n. Now again we want x1n into x2 2 minus n mod 4. So we will multiply. So this value is 1 and this is 3. So this is 3. Then you can see here it is 1 and here it is 2. So this is 2. Similarly, this is 2, this is 1, so 2, and here it is 2 and 4, that is equal to 8. Then again we will add it up, so we will get the value 15. Okay. Similarly, because the length of the circularly convolved sequence will be 4, because the length of each of the sequence is 4. So let's say we have to do another shifting. Okay. So when we will do again shifting, so this is x2 3 minus n. So this sequence will come over here, this will here, this will here, and this will here. So we will get this x2 3 minus n mod 4. Now again we will multiply by this sequence, and again we will get this 4 3 4 2, and we can do again the summation of this. So we will get the value 13. So this is how we have done the circular convolution using graphical method, and the answer that we can see here is basically 15 17 15 13, where x3n is the convolved sequence between the first sequence and the second sequence, means x1n and x2n. Okay. So this is the method which is named as the graphical method, because we have used these circles, and because we have used this circle, so this we can also call as the circle method. Okay. Now come to the another method of finding the circular convolution, that is basically the matrix multiplication method. Okay, so we will see this matrix multiplication method using basically the uh, another numerical. So again we have to find out x1n circular convolution x2n, where x1n sequence is given as delta n plus delta n minus 1 minus delta n minus 2 minus delta n minus 3, and x2n sequence is delta n minus delta n minus 2 plus delta n minus 1. So first of all we have to write these two sequences in form of sequence, or in form of a sequence like this. So according to this expression, for n equals to 0, so for n equals to 0, all these values will become 0. So delta 0, that will become 1. The first sequence value is 1. Second value is defined only at n equals to 1. So according to this we will get one value, other values are 0. Similarly for n equals to 2, we are getting values according to this, other values are 0. So this is minus 1, and last values are corresponding to this term, means n equals to 3. So this is the sequence x1n, and x2n sequence is obtained using this. So it is defined, delta n is defined only at n equals to 0. So corresponding to n equals to 0, we are having this value. So delta n magnitude is 1. So we are having one value. Then you can see there is no delta n minus 1 term. So second term will be 0 automatically. And you can see here for n equals to 2, we are getting value from this. So this is minus 1, and this is, then if you will see, there is no term corresponding to n equals to 3. So again the value is 0, and the last value is corresponding to n equals to 4, magnitude is 1. So we are having this value minus 1. Okay, sorry, you can write it like minus here. Okay, so you will get minus 1 here. Okay, so these are the two sequences for which we have to perform the circular convolution using the matrix multiplication method. Okay, now we can see here the length of the sequence 1 is 4 and length of the sequence 2 is 5. So for performing circular convolution between these two sequences, the length of both the sequences must be equal. So how we'll make it equal? You can see here the length is 4. So what we will do? We will make 0 padding here. So the new sequence x1n will be equal to 1, 1, minus 1, minus 1 and 0. So we have added 1 0 here extra. So now the length of L1 is 5 and L2 equals to 5. Okay. So this is how we have obtained the sequences x1 and x2n using the given question. And now we will perform the matrix multiplication method for the calculation of circular convolution. So it is very simple. Now how we will make it? Like here it is written. So what we will do, basically we will take one of the sequence, and with the help of one of the sequence we can make a matrix. Like let's say length is 5. So we will make a 5 by 5 matrix using this sequence x1n, and we will multiply by a column vector which is x2n with this matrix, and the result is, and the output of this matrix multiplication will gives us the value of circular convolution. So you can take this sequence and make a matrix, and you can multiply, you can take this sequence as a column vector for the multiplication, or you can also do this, that you can take this sequence for the matrix, for making the matrix, and you will multiply by this column vector. Okay. So let us suppose we are making a matrix using the first sequence. So how the matrix will you make? 1, 1, 1, minus 1, minus 1, 0. Now we are shifting like this, 0, 1, 1, minus 1, minus 1. Okay, then this element comes over here. So minus 1, 0, 1, 1, minus 1. Okay, so this comes over here, and these are like this. Okay, so these are like this. Again, this will come on the top, and this element will become minus 1, 0, 1, 1, and again when you will make it 1, minus 1, minus 1, 0, 1, and again if you will write it up, then you will get the same column. Okay, so this is 5 by 5 matrix, and we will multiply it by a column vector 1, 0, minus 1, 0, minus 1, and the matrix multiplication result will give us the circular convolution value. So this you can see here, these are the values we have made: 1, 0, minus 1, 0, minus 1, 1, 0, minus 1, 0, 1, okay, and this is the column second. So here in this result we have taken second x2n as the, with the help of x2n we have made this matrix, okay, and then we have multiplied by x1n sequence, and the result is 3 0 minus 3 minus 2 2. So this is the if you will multiply it and add it up or solve the matrix multiplication between this matrix and this column vector, you will get the final value. So this is the convolved sequence that we have obtained using circular convolution method, okay. So this is how we can calculate using matrix multiplication method. Then third is DFT IDFT or Stochamp's method. So it is also called Stochamp's method. So this method you can simply see like this, like we are having sequence x1n. Let us suppose x1k. How we will obtain x1k? X1k is basically the n point DFT of x1n, and x2k is basically the x2n, or you can also write it like this values here, okay. So so how we are getting x1n or x2n? By taking the endpoint DFT of it, okay. And so we are having x1k, we are having x2k. Now x3k can be calculated as the multiplication of these two x1k into x2k. Now, and we want x3n. So x3n will be equal to, if we will take the IDFT of x3k. So this is the simple algorithm by which we can calculate it, okay. So here the DFT and IDFT are used for finding circular convolution, okay. So x3k will be x1k into x2k, and x3n how we will calculate? This is 1 upon n summation k equals to 0 to n minus 1 x3k into e to the power j 2 pi k by n. So x1n is given as 1122. So first of all we will calculate x1k according to this expression, summation n equals to 0 to n minus 1 x1n e to the power minus j 2 pi n k by n. Now we will vary the value 0 to n minus 1. The value of n will become 4 because our sequence is of length 4, okay. So we will calculate for n equals to 4. So when n equals to capital N equals to 4, then x1k will be this expression. Now we will put the values of k from 0 to 3. So first value is x1 0. So k value 0 put here. So this will become 1. So this value will become 1. So summation of n equals to 0 0 to 3 x1n is, our sequence is 1 1 2 2. So you will add it up. So this will become 4. In for k equals to 1, you will put k equals to 1 here. So this is e to the power minus j 2 pi n by 4, which you can write as e to the power minus j pi n by 2. Now you will change the value of n from 0 to 3 and solve it accordingly. We will get minus 1 plus j. Similarly for k equals to 2, we are getting the value 0. Similarly for k equals to 3, we are getting the value minus 1 minus j. So this is x1k that we have obtained, okay. So this is nothing but the 4-point DFT of the sequence. 6 minus 1 plus j, 0 minus 1 minus j. Then we will take second sequence. Again we will calculate the 4-point DFT of the sequence, means x2k. Similar in the similar fashion. So we are getting the values 10, minus 2 plus j2, minus 2 and minus 2 minus 2j. So this is our second sequence. Now we will calculate x3k. x3k will be x1k into x2k. It means if we have to find out x30, that will be equal to x10 into x20. Okay. So x10 is you can see here 6 and x20 is 10. So this will become 60. Similarly, we can calculate all other values. Okay. Now x3n can be obtained by taking the IDFT. So IDFT expression means 1 by n summation k equals to 0 to n minus 1 x3k e to the power j 2 pi n k by 4. Now here for n equals to 0, 1, 2, 3. Okay. So we will calculate first value, put small n equals to 0 in this expression, we will get 15. Similarly, small x31 is 17, x32 is 15 and this is the 30. So this is the 15, 17, 15, 13. That is the output that we are getting, or you can say this is basically the circularly convolved sequence. Okay. But here we have solved this using the DFT IDFT means we are moving our sequence x1n into frequency domain, similarly x2n into frequency domain, and then we have done the multiplication in frequency domain, and then take the IDFT in the frequency domain to again get back the sequence in time domain, which is the circularly convolved sequence. Okay. So, these are the three methods by which we can calculate the circular convolution of two sequences. Now, next is linear convolution. So, here as I have already discussed in the introduction part that I will solve linear convolution using circular convolution, because circular convolution is the property of DFT, not the linear convolution. Okay. So, it is to be noted that the resulting sequences obtained by both linear convolution and circular convolution have different values and length. Okay. So, this we have already observed. So, linear convolution results in a periodic sequence with a length of 2n minus 1, whereas circular convolution results in a periodic sequence with a length of n. So, circular convolution will produce the same sequence values as those produced by linear convolution if zeros are padded at the end of the two given sequences x1n and x2n. Means what happened? Let us suppose we are having a sequence x1n, another sequence x2n. So, for the linear convolution, there is no such requirement that both the sequences are of equal duration. Okay, so there is no requirement of zero padding then. But let us suppose we are having a sequence x1n having, let us say, length 4 and another sequence, let us say length L2 is 2. Then the convolved sequence length in, as per linear convolution is L1 plus L2 minus 1, that is 4 plus 2 minus 1, that is equal to 5. So, now we know that the length of our linearly convolved sequence is 5. So, what we will do? We will make the length of these sequences 5 by adding zeros in it, and then we will perform the circular convolution, not the linear convolution. We will perform the circular convolution between these two sequences, but the result that we will obtain as is as per corresponding the linear convolution. Okay. So, we can see this so, this is linear convolution using circular convolution. Let us suppose we are having two sequences, Hn is 1 to 4 and Xn is 1 to. Okay. And so, first of all, we will find out the length of the convolved sequence, that will be equal to 3 plus 2 minus 1, that will be equal to 4. So, what we will do? We will add how many zeros? We will add 1 0 here, so that its length will become 4, and we will add 2 zeros here in Xn, so that its length will become 4. So, our new sequences are 1 2 4 0 and 1 2 0 0. Now, we can apply any of the studied method for circular convolution for calculating the linear convolution between these two sequences. So, here I am presenting the result using the matrix multiplication method. Okay. So, we will use the matrix multiplication method for solving circular convolution. So, you can see that the linear convolution of these two sequences is nothing but the circular convolution of these two new sequences. Okay. So, this we have done using matrix multiplication. We have made a matrix using the second sequence, so 1 2 0 0 0 1 2 0 0 0 1 2 and 2 0 0 1, and we have multiplied it using 1 2 4 0. So, the final value will become 1488. So, this 1488 is nothing but the linear convolution between these two sequences. Although we have used the circular convolution method, but because we have already zero padded the given original sequences, and we have performed the circular convolution for these two new sequences. We are performing the circular convolution for these new sequences, but the result is corresponding to the linear convolution of these original given sequences. Okay. So, hereafter the sequence are padded with zeros, the sequence values obtained by circular convolution is the same as those produced by linear convolution. Okay. Now, another topic is that filtering of long data sequences, section convolution. So, what happened generally in real time, if you will see that sequences are coming, when the sequences are coming in real time and we don't know the length of the sequence actually. So, in that case we will perform it using section convolution. So, what we will do in this case, let us suppose we are having we are doing the filtering operation. So, this is our FIR filter having impulse response Hn, and we are having a sequence Xn coming in it. And the issue is that we don't know the length of this sequence, and this sequence is coming continuously. So, what we can, that's why we are saying it is a long sequence. So, what we will do, basically we will take some of the elements of this sequence Xn and we will convolve it Hn, and we will get the output Yn for that subsequence. So, this Xn is long data sequence. So, we are dividing this long data sequence into smaller subsequences, Let's say first subsequence is x1n and then we are doing it with hn and we are getting y1n. Similarly, we will take second sequence x2n, then we will perform the circular convolution, we will get y2n and like this. Then we will finally combine all these y1n, y2n, y3n so that we will get the final result. Okay. So here the input sequence is segmented into blocks and each block is processed by the impulse response of the filter to produce a block of output data. The two methods are called, so the two methods that we can use for this is overlap save method and overlap add method. So both methods we assume that the FIR filter has duration m. The input data sequence is segmented into blocks of L points whereby assumption L is greater than equal to m. So what is the strategy? Segment the input signal into fixed size blocks prior to processing, compute linear filtering of each block separately, then fit the output blocks together in such a way that the output is equivalent to the linear filtering of Xn directly. So main advantage, samples of the output Yn will be available real time on a block by block basis. So in the overlap, first method is overlap save method. Almost both the methods are use simple, both the methods use same type of criteria, although the how we are making the subsequences is different and also how we are integrating the outputs is different. Okay. So in size of the input data block is n equals to n L plus m minus 1. So where is the length is the L is the length of the elements taken from long data sequence at a time, m is the length of the impulse response of FIR filter. So the impulse response of the FIR filter m is increased in length by appending L minus 1 zeros. Then circular convolution is performed between input data block and zero appended FIR filter impulse response sequence. So this is corresponding to the linear convolution between these two sequences. So you can understand it like this. We will understand it using a numerical. So we are having a sequence xn, which is a long data sequence. You can see the number of elements are large and filter hn having impulse response is 1 to 1 1. Now we have to perform the linear convolution between these two sequences. So this is nothing but like this is the hn and here is the xn and we are getting the yn. So what we are doing, basically we are splitting this sequence into smaller subsequences. Let us suppose we are taking this value as L equals to 5. So what we are doing, we are taking 5 sequence of this 5 subsequences, 5 elements of this sequence at a time, and length of m is nothing but the length of the impulse response. So what should be the length of n or the linear convolved sequence, that is m plus L plus m minus 1, that will be equal to 8. So what we will do? We will make the subsequences after zero padding each having length 8 because we want that our output is 8. Okay, so how we will do the zero padding? In the first sequence, we will take initially 3 zeros, then we will take 3 9 1 2 3. Then again in second subsequence, how we will make it? We will take last 3 terms, m minus 1 terms here, and then we will take another terms 4 5 6 3 4 like this. Then again we will take these 3 terms here and we will take remaining elements here. Okay. So this is how we have made the subsequences. Now we will perform the circular convolution of this sequence with hn. Now for we will perform the circular convolution, but basically it is the linear convolution. So we will take the hn length is m, which is equal to 4, but we will make its length 8. So the length of hn will become 8. So hn will become 1 2 1 2 1 1 and rest of the 4 are zeros. Now we will perform x1n convolution hn, x2n convolution hn, x3n convolution hn, x4n convolution hn, x5n convolution hn. So we will get y1n, y2n, y3n like this. So this is as per the matrix multiplication we used for calculating the circular convolution. So these are the circular convolved values. Okay. So once we will get these circular convolved values, we will write the output like these 3 values are basically the masked. So the values are output is 3 15 22 16 17, then 3 15 22 16 17, then we will take these values 13 18 23 24 21, then 22 23 28 like this. Okay, and these values are as per zero padding, so we will not take these values. So this is the final output, and we can see this is nothing but the linear convolution between two sequences. So this is how we have done this using overlap save method. For overlap add method, difference is that they are again taking the same question, but the difference is that how we are making these subsequences. So these subsequences, like we have to make the length 8, but we are taking value of L as 5, so we have to make it 8. So we will add 0 padding at the end like this. So we are having these 4 subsequences, and our impulse response is again 1 2. We will make its length again 8, 1 2 1 1 0 0 0 0, and then we will perform the circular convolution between x1n and hn using matrix multiplication. Similarly, x2n, x3n, x4n. So similarly, we will get y1n, y2n, and y3n and y4n. Now here, because this method is overlap add method, so what happened? Previously we have discarded the values, but now this time these values will be added up with the another subsequences values, like this value and added, and this value is added. Similarly, this value and these values are added. Then we will write the output like 3, 15, 22, 16, 17. Now 9 plus 4, 13, 5 plus 13, 18, 3 plus 20, 23. Then we will take 24, 21. Again these values are added. So 17 plus 5, 22, 7 plus 16, 23, 4 plus 24, 28. Then 33, 38, and then 33, and these values are added. So 41, 40, 36, and rest is 25, 12, and 5. Rest 2 zeros are due to 0 padding, so we will left those zeros. Okay, so this is again the output value. Okay, so this is how we have performed the linear convolution using overlap save and overlap add method. And the references for this video lecture is Digital Signal Processing by Seth Sullivan, 3rd edition, and Digital Signal Processing Principal Algorithms and Applications by John G. Prokis, Dimitris J. Manolakis, 4th edition. Thank you.